Welcome, Python coders, to the ultimate guide on Python list comprehensions. If you are tired of writing verbose for loops to build lists, or you just want to make your code more Pythonic, you are in for a treat. Today we will explore list comprehensions from the ground up, what they are, why they are powerful, and how to use them with practical examples from basic to advanced. By the end, you will be writing sleek one-line code like a pro. Let's dive in. In Python, it's a concise way to create a new list by processing elements from an iterable like a list, tuple, string, or range in a single line of code. Think of it as a compact for loop that lives inside square brackets. Here is the basic syntax and you can see it on the screen. So expression is what you do to each item. You might want to square it or convert it to uppercase or get the square root of it. These are all valid. Item is a variable representing each element in the iterable. List comprehensions are not just shorter, they are often faster than loops because they are optimized in Python's internals. Let's see it in action with our first example. Let's start simple. Suppose we have a list of numbers and we want to create a new list with their squares. Here's how we will do it with a traditional for loop first. You should first create a list of numbers 1, 2, 3, 4, 5, and so on. After that, let's write a simple for loop. And first, we must create another list to take squares of the numbers and put them on this list. So let's write squares equals an empty list followed by a for loop for num in numbers squares dot append num to the power of 2 and let's print squares. If we print it, we can see it outputs 1 comma 4 comma 9 comma 16 comma 25. We are done with that. Now let's do it in single line using list comprehensions. Do something like this. Squares. Let's do it using list comprehension. So num raise it to the power of 2 for num in numbers. And after that, let's print it again. And if I do that, you can see the same result appears. One line, same result. The expression is num to the power of 2 and the item is num and the iterable is numbers here. This is the essence of list comprehensions, clean and efficient. So, a new list is created by using this list comprehension. Keep in mind, you have to be careful here and write your expressions in the correct form. You put your expressions here, you put your item here and your iterable here and assign it to list of squares. Can filter items in a list comprehension using an if clause. Let's create a list of even numbers from 1 to 10. First, the loop way. Create a list names evens equals an empty list. After that, a for loop for num in range. Remember how we can create 1 to 11. 11 is not included if you remember. So after that, if num modulus 2 equals 0, so if it's an even number, evens dot append num, and let's print it. Print evens. As you can see, it prints 2, 4, 6, 8, and 10. Now let's do it in Pythonic way, so I will use list comprehensions. Let's type evens equals num for num in range 1 to 11. So if I only run this, we will get something like this first. So we will get 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If I add an if clause to this, to the end of it, like this, if num modulus 2 equals 0. Yes, you can actually do that. So you here bring a condition and it adds even numbers. So let's print it again. So it prints out 2, 4, 6, 8, and 10, same as the above. Notice how we didn't need an expression beyond num, and sometimes the item itself is what you want. Let's try another example. Let's work with strings. So, say you have a list of words and you want only the words longer than 4 characters, converted to uppercase, of course. Here's the list comprehension for that. So let's type words equals cat, duck, python, rat. After that, let's create another list, long word, say, equals word dot upper. So here's our expression. What we want to do is to convert it to uppercase. So we write that for words, for word. So our item in words here is iterable if len word greater than 4. And here's the if clause. After that, I will just print long words. So as you can see, it only prints Python. Here, the expression word.upper transforms the word, and the condition if len word greater than 4 filters out short words. Now let's explore more advanced scenarios. What if you want multiple conditions? You can chain if clauses. Let's get numbers from 1 to 20 that are both even and divisible by 3. So let's create a list named numbers equals to range 1 to 21. Special nums, let's call it special nums equals and write our list comprehension num for num in numbers if num modulus 2 equals 0 and if num modulus 3 equals 0. That's all. Just type it next to it. Each condition here acts like an AND operator. Only numbers satisfying both num modulus 2 equals 0 and num modulus 3 equals 0 make it to the output. Cool, right? Let's print it. Special nums. As you can see, it prints out 6, 12, and 18. You can use functions in the expression. Let's create a list of lengths of words, but only for words starting with P. Let's type words equals, it's a list, Python, Perl, which is another programming language, program, and PyTorch, which is a Python library. Now, lengths equals len word for word in words if word dot starts with P. And let's print lengths. The first one is 6, second one 4, and others are 7. It's true. The expression len word computes the length. So here's the expression. And the condition is word that starts with P filters for words beginning with P. List comprehensions are not limited to lists. They can process dictionaries too. Let's extract keys from a dictionary where values are above a threshold. So let's define a dictionary named scores equals Alice 85, Bob 92, and Charlie 95. So hike scores, hike dot underscores. Let's filter it out equals name for name, comma, score in scores dot items if score greater than 90 and print high scores. As you can see, it prints out Bob and Charlie. Here we unpack each dictionary item into name and score using for name score in score.items. The condition if score is greater than 90 filters for high scores. This is super handy for data analysis. Let's tackle nested list comprehensions. Suppose you have a 2D list, in example a matrix, and you want to flatten it into a 1D list. Let's first define a matrix equals. We haven't seen it yet, but if you want to define a row, we will use another set of square brackets. So 1, 2, 3 is a row, 4, 5, and 6 is a row, and 7, 7, 8, and 9 is a row. And here is a 3 by 3 matrix. So you want to flatten it. Let's define a list name flattened equals, write our list comprehension num4 row in matrix for num in row. This is equivalent to two nested loops. First, looping over row in matrix. So num for row in matrix is our first loop, and for num in row is our second loop, looping over rows. It's powerful but can get tricky, so use it sparingly. If we print it, print flattened, we can see it is 1, 2, 3, 4, 5, 6, 7, 8, 9. So all numbers are included, but if you print the matrix, you can see it was a matrix before, and after the flatten operation, it became a 1D list. Now let's talk about enumerations. You might want to include indices, so you should use enumerate. Let's create a list of strings combining indices and values. So let's define fruits equals apple, banana, and orange. Then let's define index equals a formatted string I fruit for I, comma, fruit in enumerate. What we are going to enumerate an iterable, so it's fruits, so it will enumerate it as index value, and index value. So let's print it indexed, and as you can see, 0 apple, 1 banana, and 2 orange. Before we wrap up, let's talk best practices. First, you should keep it readable. If your comprehension is too complex, in example, nested loops or multiple conditions, a regular loop might be clearer. Secondly, you should avoid side effects. So don't use comprehensions for actions like printing or modifying variables. Stick to creating lists. Third is memory usage. Comprehensions create the entire list in memory. For huge datasets, consider generators, a topic for another video here. And that was a deep dive into Python list comprehensions. We covered the basics, added conditions, explored advanced use cases, and saw many examples. Querying numbers, filtering events, transforming strings, handling dictionaries, and more. List comprehensions are cornerstone of Pythonic code, and I hope you are excited to use them in the projects. If you enjoyed this, hit that like button, subscribe for more Python tutorials, and check out our new videos. Thanks for watching, and happy coding!